Lesson 1. Let's start by defining the square root of x squared. Oftentimes, some people will say the answer is x. Other times, people will say the answer is plus or minus x. They are both wrong. If I asked you to review from a previous course, what is the square root of 9? Well, sometimes people get complicated and say it's plus or minus 3, and that is incorrect. The square root of 9 is simply 3, and only positive 3. Now, the square root of negative 3 squared, well, that would be also 3, and only 3, the positive root. So we define the square root of x squared to be only the positive root, so the absolute value of x. We call that the principal square root. Mathematicians have agreed to allow the square root to be functional, meaning it can return only one value, and it will always return the positive value. Now, of course, there will be times when you'll get an answer to be plus or minus 3, and we'll investigate that here. But first, let's define something else. Let's define the absolute value of x. Now, sometimes people will say, well, that's the distance from 0 on the number line, and they are correct. Now, if you were a computer programmer and you needed to say that the absolute value of 3 returns only 3, and the absolute value of negative 3 would return, again, positive 3. Well, how do we get that to be? Well, a programmer can use piecewise function, conditional statement. We will say that the absolute value of x is simply the inside or itself, provided that x is positive or 0. So x is greater than or equal to 0. Now, in the event that x is a negative number, well, then we need to take the opposite of x, and that's provided that x is less than 0. You can see that here. When the number x is positive, it returns itself. When the number x is negative, it's going to be the opposite of negative 3 to return positive 3. Suppose you are asked to solve the equation x squared equals 9, a very simple equation to solve. Most of you know that the answer x equals plus or minus negative 3. Now, is that a contradiction to what I was speaking of? Well, let's take a look. I'm going to first take the square root of both sides of the equation. Let's take a look at the right-hand side. Now, the square root of 9 by the principal square root discussed above is simply 3 and only positive 3. It's on the left-hand side that sometimes we forget, and this is going to be the absolute value of x equals 3. It is at this point we say that the inside can be 3 or the inside can be negative 3. And it's not because the square root of 9 is plus or minus 3. It's not. The first page of notes is going to involve writing absolute value functions without the absolute value into a piecewise function, employing the definition above. First one here will be very simple. We're going to say that f of x equals, and we're going to use this silly bracket to define conditions, and it's going to equal itself. Now, itself means the inside. Here's itself, and that's provided that this quantity is greater than or equal to 0. This is the interior, so it equals the interior provided that the interior is greater than or equal to 0. It's going to equal the opposite of the interior, provided that the interior is less than 0. Next, I want to simplify, so we have it's going to equal 3x minus 2, and I'm going to solve this inequality, adding 2 to both sides and dividing 3. So this is going to be when x is greater than or equal to 2/3. I'll distribute the negative, and I like to put the constant first, so I'll say 2 minus 3x, and that's provided that x is less than 2/3. Let's take a look at the second example, g of x. Notice that there is an absolute value, but the absolute value is not alone. It's accompanied by a 5, and then it's minus the absolute value. I still want to identify only the interior of the absolute value. So we're going to say that g of x equals, we'll write our bracket, 5 minus, it will return itself, 5 minus x plus 1, provided that x plus 1 is greater than or equal to 0. The interior greater than or equal to 0. It will be still 5. 5 is not connected to the absolute value. It's not inside the absolute value, rather. So we keep the 5. We keep the minus. But now I'm going to need the opposite of x plus 1, provided that x plus 1 is less than 0. Simplifying this, we have 5 minus x minus 1, I distributed. Here I'm going to solve the inequality, so that will be x is greater than or equal to negative 1. Okay, down below, the negatives will cancel out, so I'll have 5 plus x plus 1, provided that x is less than negative 1. We need to simplify this further still, and so this is going to be 4 minus x, provided that x is greater than or equal to negative 1, and finally 6 plus x, given that x is less than negative 1. Example number 3, y equals the absolute value of x plus 2 over x plus 2 without absolute value. Let's write it. So y equals the interior, x plus 2, over x plus 2, provided that x plus 2 is greater than, careful, I'm not going to say equals here. I can only say greater than 0. See, if I allowed this quantity x plus 2 to equal 0, then it would show up in the denominator as 0, and hopefully you know that that is a big no-no. On the bottom of this condition, we will say it's the opposite of x plus 2 over x plus 2, provided that x plus 2 is less than 0. There is no equal to 0 here. Simplifying this, okay, so x plus 2 over x plus 2 is clearly the number 1, the constant 1, provided that x is greater than negative 2. And the second condition, it will be negative 1, provided that x is less than negative 2. Example 3 calls for us to graph the function y. So I'll draw a quick set of axes. Here's my x-axis and the y-axis. I'll label a couple markers here, a couple markers here. This is negative 2. Here I'll count off by ones. 1, 2, negative 1, negative 2. Okay, so let's graph this function y. Well, when x is bigger than negative 2, so here's our deciding x. When x is bigger than negative 2, it's the constant of 1. I'll put an open circle because it can't equal, x cannot equal negative 2. And that will continue on forever. When x values are less than negative 2, well, then the constant is negative 1. Two separate horizontal rays. Example 4 is a little bit more tricky. H of x. Before I rewrite this using conditions, I want to see that I have here the square root of x squared, which we've learned already is the absolute value of x. So we're going to subtract the absolute value of x plus x times, again, the same absolute value of x. And since these two are the same absolute value of x's, that's going to make things a little easier. Now we have our conditional statement. So it's going to be 4 minus regular x plus x times regular x, provided that regular x is greater than or equal to 0. Then on the bottom, it's going to be 4 minus the opposite of x plus x times the opposite of x, and that's when x is less than 0. Ready to do some simplification? So we have 4 minus x plus x to the power 2, or x squared. And the bottom part, or bottom condition, is going to be 4 plus x minus x squared when x is less than 0. Example number 5, f of x is the absolute value of 2 minus x, and then plus 1. I would encourage you to press pause, work it out, and then follow along afterwards to see if you're right. Press pause now. Okay, I'm going to do it. So f of x equals 2 minus x as we see it, plus 1, provided that 2 minus x is greater than or equal to 0. The opposite? Oh, and the opposite will be x minus 2 plus 1 when 2 minus x is less than 0. If you know how to skip this condition and go right for the kill, that's fine, but please be careful, and you might see that here. Okay, I'm going to simplify the top, which is going to be 3 minus x, provided that, now really, honestly, be careful here. Subtract 2 from both sides, and then we're going to divide by negative 1. But when we do that, it flips the inequality. So you want to make sure that you didn't overlook that portion. Same is true down here. Subtract, divide, and so our result is going to be x minus 1, provided that x is greater than 2. This question also wants you to graph. Now, in an earlier course, you may have been able to take this and graph it. You should know it's a V-shape. There's going to be some reflection here and some shifting. But we're going to bypass that and look at it from a different perspective now. We're going to look at it as if it's a piecewise function, which it is. So I'll mark these off as 1, 2, 3, and 4. That ought to do it. And then let's see, 1, 2, 3, and 4 here, making this a fairly rough and quick sketch. Let's do it in some different colors. So we're going to graph this function first. That's when x is less than 2. Here's our value of 2. When x is less than 2, we have the function 3 minus x, which has a y-intercept of 3 and a slope of negative 1, so it goes down 1 over 1, down 1 over 1. And so that's a line, but it's really a ray because it has a condition assigned to it. Now we take a look at the other portion, and that also a linear function, this time a y-intercept of negative 1 and a positive slope 1, up 1 over 1, up 1 over 1, but that doesn't start until we get here, so it's really an open circle when I'm dealing with the yellow. And then I go up 1 over 1, up 1 over 1 to make the other part of the V shape. And there we go. If I trace the entire thing, the circle was closed and open at the same time, so the closed portion fills in the open portion, and we have the V shape, which you could have graphed prior to taking this class. Last example of the page. Why don't you go ahead and solve this one, press pause, and when you come back, we'll have the solution. Solution revealed.